Let's take a look at the addition rule and complements. And first we'll look at a definition. Two events are disjoint if they have no outcomes in common. Another name for disjoint events is mutually exclusive events, and this will make more sense once we start talking about some examples. Um, if let's say we got 5 women in a class, 2 have glasses. And we got 3 men, and none have glasses. Well, if I look at the probability, for example, of picking somebody out at random from the class who's either a man or has glasses, these are mutually exclusive because there's no men that have glasses. So this is going to be completely separate from that. Now, if you compare that against, if I look at the probability of picking out a woman out of the class, or somebody has glasses. Well, this one right here, since 2 have glasses, we'll count the women here, but we also count 2 of the women here that have glasses. We'll count them twice. So that's the idea of them being mutually exclusive. Now, this first formula is where we got disjoint events. This is where they're mutually exclusive. And the probability of E or F is equal to probability of E plus probability of F. So again, this is like the picking somebody out at random who's either a man or has glasses. E and F have nothing to do with each other. Now, I put probability of A or B up here, but you can have any variable, E, F, G, H. Now, if you got a general probability addition rule, this is where you need to worry about what do they have in common. So probability of E or F is equal to probability of E plus probability of F minus probability of E and F. And then we got our complement of E. This is represented by E bar, or E to the, looks like to the C power. To calculate, find a probability of E occurring and subtract from 1. Consists of all outcomes M which event E does not occur, and consists of all outcomes M which event E does not occur. Okay. So probability of the complement of E is equal to 1 minus probability of E, and we'll talk more about that. Let's look at some problems. Now, S is equal to 1 through 10. Excuse me. And E is 1 through 5. And let's look at that first. Okay, now S is everything. That's our sample space. So that's all of our possibilities. And E is 1 through 5. So this is asking us to list the outcomes. Well, this is a complement of E. So if we take our sample space, which is everything, and I subtract off E, that what it's saying in notation is this is saying 1 minus E. Now 1 is everything. Like that. And then we're subtracting off 1 through 5. Excuse me. Well, if I take that list here, and if I subtract off 1 through 5, that's going to leave me 6 through 10. So this will be 6, 7, 8, 9, and 10. So that's how the complement works. You take 1 is everything, minus whatever's in E, and then that leaves you what's left. That's part A. Now B, it says E or F. Well, E is 1 through 5. And F is equal to 1, 3, 5, 7, 9. 1, 3, 5, 7, and 9. So we got E or F. What we're going to do here is we're going to merge these into one set and not repeat any. So any that are duplicated, we don't write it down. Well, E is 1 through 5. Now if I go over F, it's got a 1, I already wrote 1 down. It's got a 3, I already wrote 3 down. It's got a 5, I already wrote 5 down. And then we got 7 and 9. So in OR, we write down, we merge the two sets together and not write any repeated. Then E or G. Well, E is 1 through 5. And G is 8 and 10. And E or G, I'm going to merge them together. So I got 1, 2, 3, 4, and 5. And 8 and 10. Now notice they didn't have anything in common, did they? These are mutually exclusive. They don't have anything in common. These had some items in common. These are not mutually exclusive. So we had to subtract off the extra elements. Let's take a look at this one. Probability of E is equal to 0.20. Probability of F is equal to 0.30. And A says find, we want to find probability of E or F. If the probability of E and F is equal to 0.10. Okay. Well, let's go up to our, well, I don't need to go up to our formula, I remember what it is. Our formula said, this is our general addition rule, probability of E or F is equal to the probability of E plus the probability of F minus the probability of E and F. Well, probability of E we said was 0.20. Probability of F is 0.30 minus, they tell us probability of E and F is 0.10. Well, it gives us 0.5 minus 0.1. We get 0.40. And that's our answer. Now B wants us to find a probability of E and F. If the probability of E or F is equal to 0.25. Okay, so we're going back to our general addition rule. We've got probability of E or F is equal probability of E plus probability of F minus probability of E and F. Well, they tell us probability of E or F is 0.25, so put that in for that. Probability of E up here is 0.20. Probability of F is 0.30 minus probability of E and F. Now we treat this like a variable. So I'm going to take that and I want to move it over to the left side. I'll take this and move it over to the right side. So we've got the probability of E and F. Remember, when you take anything across your equals, your sign changes. is equal to 0.20 plus 0.30 minus 0.25, which gives us 0.25. And I'm about out of room here, but it says to find probability of E or F if E and F are mutually exclusive. Well, probability of E or F, if they're mutually exclusive, is probability of E plus probability of F, which they tell us probability of E is 0.20, probability of F is 0.30, so that's going to give us 0.50. Now, D, probability of complement of E, that's equal to 1 minus probability of E, which probability of E is equal to 0.20, which gives us 0.80. And last one, probability of the complement of F. That's equal to 1 minus probability of F, which is 1 minus 0.30, which gives us 0.70. And those would be your answers. So on that problem, all we're doing is using these formulas up here and plugging in whatever value they gave us. And here's our complement of E. I'm going to go ahead and save that. Addition rule and complements. Yes. Addition rule and complements. Page 01 PDF. There we go. So let's look at our next problem. It says probability of E is equal to 0.30. Probability of E or F so E or F is equal to 0.90, and probability of E and F is equal to 0.05. Then it says find probability of F. Well, here's our general addition formula. We got probability of E. Oops. I guess I better write correctly. Probability of E or F is equal to probability of E plus probability of F minus probability of E and F. So let's plug in what they give us. They tell us probability of E or F is 0.90. Probability of E is 0.30. We don't know probability of F. That's what we're trying to solve for. Minus probability of E and F, they tell us is 0.05. Well, add these together, or subtract them. 0.30 minus 0.05 gives us 0.25. Then I'm going to take that over to the left side. Anytime you take anything across your equals, your sign changes, so that becomes negative 0.25 equals probability of F. And then subtract those, and I get 0.65 is probability of F. And that's our answer. Let's look at this problem. It says find a probability, and we're given a probability model here. A says find a probability of getting red. Well, we just look this up in our table. The probability of red is 0.20. Now B says find the probability of getting red or blue. So red or blue. Well, with the or, we add them together. So we're going to add together the red and the blue. So we've got 0.20 plus 0.30. Now, there's no way that it can be red and blue at the same time. These are two separate items on our table. So we just add them together, and we get 0.50. C says find the probability of not getting yellow. So probability of not yellow becomes 1 minus probability of yellow. This is using the complements rule. And if we look up probability of yellow, that's 0.40. So 1 minus 0.40 gives us 0.60. Let's take a look at our next one here. Okay, so we got age 20 to 29, 30 to 39, 40 to 49, and 50 to 59 in hours. 35, 70, 20, and 10. Now I'm leaving some items out of this. I'm not writing, there's a, everything's random. Everybody has an equal chance of being chose, blah, blah, blah. Now this says find a probability that's between 20 to 29. Well, we have to build a probability model first. So if you're given a table and it's asking for probabilities, then you have to go through and create that. So I'm going to add these together. That's 105, 135, I believe. Let me add that in my calculator just to make sure. I don't want to have an error in my video. 135. Okay. So then for our probability, we're going to take each one of these amounts, take 35, divide by 135, take 70, divide by 135, 20, divide by 135, and 10, divided by 135. 35 divided by 135. I'll take these, 4 decimal places to get. 0.2593. And this one will be 0.5185. And next one, 1481. And last one, 0741. Okay. Now part A. Find a probability that between 20 to 29. Well, in this one, here's 20 to 29, here's my probability. So my answer would be 0.2593. Now B. It says find a probability of 40 or greater. 40 or greater. Well, here's 40, 40 through 49, 50 through 59. So that would actually be these last two. So I'm going to add them together. So 0.1481 plus 0.0741. 481 plus 0.0741. So we'd end up with 0.242s. And that'd be your answer. Let's take a look at problem number 6. Now I think I'll start a new page. So given a standard deck of cards, and a card is pulled out at random, you know, all of them have equal chance being chose, so forth. A. Probability that we're going to get a diamond, or we'll get a king. Well, or is always plus. That's 52 cards. There's 13 diamonds. For the king part, there's 52 cards. There's 4 kings. Now, a problem with this is what you have to think of on each of these problems, is we counted the king of diamonds in this first fraction. We also counted the king of diamonds in the second fraction. So we're going to have to subtract off one of those. So that's 16 over 52, which gives us 0.3077. Now B. Probability ace or queen. Well, for our first fraction, again, the or is addition. For our first fraction, ace. Well, it's 52 cards, 4 of them are aces. For the queen, it's 52 cards, 4 of them are queens. Now, there's no way for a card to be an ace and queen at the same time, so I don't have to subtract anything off here. So this will be 8 over 52, or 0.1538. Now C says probability of clubs or heart. And again, there's the or is plus. There's no way for it to be a clubs and heart at the same time, so we don't need to worry about subtracting anything. There's 52 cards, 13 of them are clubs, and on this one, it's 52 hearts and 13. There's 52 cards, and there's 13 of them are hearts, which would give us 0.5. 26 over 52. And part D, red card or queen. So red or queen. Well, there's 52 cards. 26 of them are red. There's 52 cards. 4 of them are queen. The problem here is 2 of these queens we counted here, or 2 of the cards we count as red are queens. So we need to subtract off 2. That gives us 28 over 52, or 0.5385. And that's our answer. Take a look at this problem here. Okay. Number 7. Okay, so I came up with a table. This is the age range across here, and then I counted how many use Facebook, how many use Google+, and then I totaled these. So, for example, this 50 right here says that for 18 and 20-year-olds, 50 of them use Facebook out of the sample I did. 21, 23 of them use Facebook. 5 of them use Google+, 10 of them, so and so forth. So A, if someone is chosen at random, what is probably they use Facebook? I'll just do F for Facebook. Well, if someone is chosen at random, was probably they use Facebook. If I come over here, my total Facebook users is 80. So we'll put the 80 over our grand total, which was 115. Now, B. If someone is chosen at random, what is probably there 24 to 26? Well, there's still 115 people total. For the 24 to 26 column, there was a total of 30. So we'd have 30 over 115. I'm not going to actually plug these in the calculator, but C. If someone is chosen at random, was probably their 21 to 23 Google Plus user. What this is saying is they're saying they're 21 to 23, and they're a Google Plus user. Now, when you're talking about an and in a table, it's the intersection. So I look at the intersection of 21, 23, and a Google Plus row, and that gives me 10. And then we put it over a grand total. So it'd be 10 over 115. Okay, D. If someone has chosen random, was probably either 18, 20, or a Facebook user. So probability of 18 to 20, or they're a Facebook. Well, the or is addition. Got 115 total. 18 to 20. There's 55 of them. For the Facebook, there's 80 of them. Okay, 18 to 20 and Facebook. I don't know if I can actually do this unless I make it full screen. Let me try that. Not a very big one, but okay, so I added 18 and 20. So I added this column right here. I also added the Facebook. This right here. Well, you notice I added the 50 twice, didn't I? So I added it in this column. I also added it in this row. So I'm going to need to subtract off the 50. So over here, I'm going to do a minus 50 over 115. Again, I added this column here, I added this row, and I added that 50 twice. Added it for this, and I added it for this. So we have to subtract that off. And I think that gives us 85 over 115. Yeah, 85. Let me save this. I think that was the last problem. I think my little tablet went kind of funny. There it went. There we go. Now let me stop the recorders. Silly dogs barking.